Welcome to Lesson 3, Variables. In this lesson, we're going to explore how to store information, to learn about the different types of information we can store, and then to finally do some kind of operation with that information. We're going to do this by learning a concept called variables. Now, variable directly connects to the first part of the title of this course, which is information. The second part of the title will be covered in a future lesson, which is intelligence. How do we give something intelligence? So just realize that programming concepts are going to get connected to the title of the course and the whole purpose of why you're learning what you're learning. Now, variables is not exclusive to programming. You've been dealing with variables from your math classes, your science classes. In a math class, you might have had a problem where the length of a rectangle was equal to 10. Well, that means that length is equal to 10. Length is a variable. In a science class, you might have had a physics problem where the mass of an object was, 32.8. Okay, so mass is equal to 32.8. This also leads us into the other concept that's on the slide, which is data types. Length is a whole number. That's something called an integer. Mass, which was 32.8, is a decimal number. That's another data type, sometimes referred to as float or double. Even further into the idea of data types, not all information falls into the category of numbers. Information could be words, such as name is equal to Castro. All right, so Castro is a word. Those are letters. It's not a number, but it is still a type of information. Before we go into Arduino, we have to cover some rules for creating our variable names. We just can't use any word to represent information. So as part of our rules, variables have to start with a letter. They can contain numbers as long as it's not in the first position, which refers back to rule number 1. They can contain spaces. I know sometimes it makes it more readable to see spaces between words, especially if you have a sophisticated variable name, but you can't have spaces or special characters. The only one that's allowed is the underscore, and that's what a lot of people use to mimic the idea of a space. Again, you'll get a lot more practice as you start creating variables. But again, this is just to kind of talk about it up front so that when we start going into it, you realize these are some of the things you have to do. Number 4 is not crucial to the program, but it's crucial to you as a programmer. To use meaningful names for variables. For instance, going back to our math problem where length is equal to 10, I would not call my variable cookie. Okay, cookie equals 10 doesn't describe that 10 really meant the length of a rectangle. So you're going to want to use variable names that are connected to the problem. And lastly, you're not going to want to use words that are used by the language itself. And again, this will come with practice. Now, if you're using an IDE, it usually gives you a hint because keywords are usually colored a different color. So let's get to it. Let's get some practice. So let's open up our Arduino. So we're going to create variables by listing them up top. And the first thing we have to specify when we create a variable is the type of information it's storing. So let's play around with whole numbers, integers. And the way we specify to a computer, to a program, that we're going to create a variable to store integers is by writing the word int. And we'll do x equals 10. And let's go to our serial, our loop. Let's do a serial print line of x. And let's see what we get. It's connected. So one thing to note is that even though this particular example doesn't affect the Circuit Playground Express, you still need to have it connected in order to upload the program and run it, because the program is actually executing on the Circuit Playground Express. All right, so now that we have it uploaded, let's take a look at our serial monitor. And we'll see the value 10. Notice we don't see the letter x. X is a variable. So when we use x, we don't see the x, we see the value of x, which happens to be 10. All right, so let's expand our example in that, let's create another variable. Now when you create multiple variables of the same data type, you can simply put it on the same line by doing this. Or you could, if you want to, and sometimes for readability purposes, it might make sense to put a variable on a separate line. Okay, and that's up to you. I could have put the z up here by putting a comma z, or I could put it down here. The other thing you'll notice too is that I haven't given z a value. That's okay as well. The important thing here is that we've identified to the program that we have a variable that will store some information, and that information will be an integer. So moving into our loop, we can now give z a value because I want z to be equal to x plus y. And notice how I said it very kind of calmly. And that's hopefully something that you pick up when you start programming more, is that program is really just an extension of our natural language. Think about what you want to do, say it, and the code's going to come out close to it. So looking at our example, if x is equal to 10 and y is equal to 20, I think you can kind of figure out what's going to print out if I do print z. Let's try. And as practice, I would definitely encourage you, before you run programs, try to envision what the output would be, and then when you run it, you get a chance to kind of test out your hypothesis. So let's see. And there we go, we got 30. So these have been integers. As we said, not all information falls into whole numbers. So let's create a variable called float. Now float is used to represent decimal numbers. So let's create a variable called a, and it's equal to 3.5. And let's create another variable b, but let's not give it a value. And now inside of our loop, let's set b equal to a plus z. So here's a, similar to the other one, z got its information from x and y. So depending on what values I have for x and y, z will get its value from that. Now b is similar in the same idea that it's getting this information from a, which is up here, but now it's getting its information from z, which is getting the information from x and y. And if you think about like the real world, that's not an uncommon idea. The idea that information gets passed around. We see that with human beings. You know, somebody tells somebody some information, which then they have to tell somebody else in order to get the job done. Well, programs work the same way. So B, in order for it to get its information, it has to rely on A, which has the information, and Z, which has to get its information from X and Y. All right, so let's go ahead and print out B, and let's see, what do we got? We got 10, 20, and 3.5. Let's see. And there we go, 3.5. Now we've kind of nonchalantly kind of like just threw in some mathematical operations in here, but hopefully everybody feels comfortable that if I wanted to subtract the two numbers, I can do this. And what I'm going to do is I'm going to do a bunch of prints in order to kind of cover all the operations, all the basic operations. And within each print, I'm also going to do a tab. Which will allow us to get various pieces of information all on the screen at the same time, all in one line. Again, the Arduino is not meant to really work like this, so this is not the most comfortable environment. Actually, yeah, let me do one more of those. And I'll make the last one the print line. All right, so we had the addition, so I'll put the addition back in. We have subtraction. Multiplication, if you're not familiar, is the asterisk, which is above the 8. Here's division. And those are your basic operations. And I'm going to do this with the last print line. Now, something else that you're noticing in this example. Notice how I'm using information from B, I'm doing something with it, and then I'm modifying it. Remember, the computer's serial in that it goes top to bottom, left to right, evaluating, well, actually evaluates from right to left, but definitely top to bottom, the sequence of instructions. So this B value that gets printed here is this V value that got manipulated here. This B value is this one. So I don't want you to think that all of these are going to print out the same information. No, information is changing as it goes. And again, making back the analogy to the real world, that's what happens. You know, you can't just stay with the same piece of information, especially in business. Information is constantly changing. You're constantly having to modify or recalculate things. Well, the program does the same thing. All right, so let me just check everything. We should get everything correct. And I think we're ready to print this out. Not quite sure what all the answers are. I haven't done the math in my head, but you know what? Let's let the computer do it. All right, so let's see what we get. And okay, so we knew the 33.5, the subtraction, there you go. The division, actually I wasn't sure that this was going to turn out, actually this is the multiplication, this is the division. So you can see division produced a decimal number of 0.12 because it ended up being, what was that? A was 3.5 divided by 30. So these are your basic math operations. I'm not having it demonstrated here, but you can also put parentheses. It's the whole idea of parentheses, order of operations, parentheses, math division, addition, subtraction. All the rules of math apply to a programming language. They have to. All right, so let's get back to our slide. So we covered a lot today. We talked about variables, how to store information, that each piece of information inherently has some type to it, whether it's integer, float, and some other ones such as strings, Boolean. But primarily for the circuit playground, you're going to deal with integers and floats. And we concluded our example with just an explanation of some basic math operations, arithmetic operators, such as addition, subtraction, multiplication, division. Though it wasn't demonstrated, parentheses work in there as well. All the rules of mathematical operations apply to a programming language. Thank you.